All right, cool. Good morning, everyone. Again, my name is Kwana Yazi. My deshkijin nishlin, ajitane bashischin, bitahinashchedo, the Bethlehem National. I am originally from Rock Point, Arizona. I'm one of the professional tutors here. I specialize in English, writing, and Navajo. But today's segment is actually going to be a continuance of yesterday. So we're into day 2 of finals countdown. So this morning, I think today we only have 2 sessions, which right now is the Math 100, I believe, equations. Let me check really quick. Linear equations and inequalities, which Terrence will be going over as well for this session. So we'll be going through that portion. Then at 3 o'clock, we have Finding a Voice with Joyce, where she'll be explaining how to use tone and mood within your essay papers and stuff like that. So that's the schedule for today. So 10 o'clock to 11, and then 3 to 4 o'clock today. So again, I'll be going through, just keep up to date with dclearningcenter.com. That's where everything's being posted. Details about each session. And then we also have that drawing, gift card drawing that we're doing as well. So your participation actually counts to the how many sessions you attend counts to which gift card drawing you'll be entered into. We have a $25 one, $10 one, and $15 $25 one, a $50 one, and a $100 one. So just keep in mind that an evaluation will be sent closer to the end of this session, which is how we're keeping track with accounting you for those sessions that you're attending. So I'll go ahead and end at that, and I'll go ahead and turn it over to Terrence, who will be going over linear equations and inequalities.
Good morning, everyone. My name is Terrence Leno. My clans are Kia Ani and Swintabahabashi, Sitnajani Tashanita Tashanella. And what I'm going to be going over is linear equations and equalities. There's going to be a couple sections that I'm going to touch base on and slightly go over just as a refresher. There's solving equations, inequalities, interval, notation, union, and compound inequalities, intersection, absolute value equation, and formulas. In the formula part, there's 3 sections to it. There's the perimeter, and there's area, and there's volume. And we'll start with the first one, solving equation sets. When we're solving equation sets, our first example would be equals 3 plus blank, and then okay, the first part of it is they just want you to predict what numbers would actually satisfy this equation. They just want you to really get into use of thinking of it, like what numbers would add 3 would equal 9. And the first, this first section, this one, you could just throw in any number. It could be, in this case, it would be 6. 6 would be the only number that would satisfy this solution. And that would be just part A. But when we get into parts B, C, D, they want you to kind of like get used to isolating. And when they want you to isolate, they want you to get the value of X, Y, or whichever letter they give you. They want you to get that value alone. So when we have an equal sign, they want you to, when you subtract 7, you subtract one side, you do to the other, and then n is going to equal 14, 15. And then that's your addition and subtraction. It works vice versa. If it was a -7, we would add 7, and then that would change that whole value. And in this one, when we're multiplying, when we have x times 3 equals 63, we have to do the opposites, just like we did with the addition. We subtracted, we also got to do the opposite, the inverse of it. So in this case, we would divide it by 3, divide that both sides. And 3 divided by 3, that equals 1. So the x is going to become by itself. And then 63 divided by 3, I believe that would be 21. And all that is saying is 21 times 3, you're going to get 63. And then that works the same way with this one should have been up here, but that's fine. We have t plus 28 equals 64. If we were to subtract 28, what would we get as our t value? We would get 26. And then that's basically how solving equation sets works. We have a times x equals y, and all they want you to do is just isolate. That's all this portion of, that's all this part is. It's just they want you to get used to isolating. Any questions? None? Moving on to inequalities. Inequalities is we're dealing with less than, greater than, or equal to, or not equal to. So this sign here is going to be our less than sign. And this sign here is going to be our greater than sign. And this sign with the equal, that's not equal to, with the slash in the middle. And we can be given a lot of different types of inequalities. We have a number line here. And we could be given something like -1 and 3, 2. Let's go 2. -1 is less than 2. And that's all that that is saying with that. And we could go with other, it just depends on, you just got to read it like a sentence. That always worked for me. Like we could have a -1 to -4, and that would be -1 is greater than -4. And there's a lot of, after, and the reason why I'm touching base on this is because interval notation union, that is when you see a problem that looks like this. A, B, X, A is less than X less than B. All this is saying is that when you're any, A and B can be any number. And when you write that out in a number line, you're going to, all that is saying is that it is restricted to include A and B. Like we could have B here and we could have A here. And all that is saying is that it is including everything that is on the number line and including these endpoints. And you draw your, you have your parentheses within that number line. And you can also be given a different value where you have your brackets. And same thing, it's gonna have your X. And the only time you'll add your brackets within your number line is when you have this sign, you're less than or equal to. And that's the only time you'll have to add the brackets within that equation. And sometimes, and in other times you'll get equations where you'll have both. Your less than or equal to is less than this so-and-so number. And then you'll be adding both of them. I'll give you like 2 examples. We could have A and then B bracket. X. You could be given something like that, and all you're gonna do, you're gonna write it out the same way. Find the B value, which you're gonna put a bracket in there, and your A value is gonna have your parentheses. And all that is saying is that it's not including what is on this point, but it is including what is on this point on your A. And it works both ways, and you could, and vice versa. You could have the less than or equal on this side, and this side could not have it. And all that's going to do is switch these two signs, the bracket and the parentheses. And in other equations, you could begin like a to infinity, positive infinity, where that's going to look like x is greater than a. And in that case, it's going to be not including a here and everything to infinity. So it's going to be going to your positive direction. And those are some examples of, or that's ways to draw the number line. Draw them out on the number line, inequalities. Any questions? I'll do an example, a problem example. We could get a problem like x plus 5 is greater than 1. And you could look at this like an equal sign, but just remember that you have your greater than or less than sign, so we want to keep that there. And we got to subtract 5 here. And what we do to one side, we got to do to the other. We got to keep a balance of power. And then we're going to have x is less than 4. And all that is, and you could just, and that's kind of like how it is. X is x 4 bracket. Yeah, or you could write it like this with your parentheses, -4 to infinity. Either or should work when you want to write your final answer. And sometimes, most of the time, you'll be getting questions like 16 minus 7y is less than or equal to 10y minus 4. You could get an equation like this, and all they want you to do is bring your values to one side and your whole numbers to the other. And when you do that, all we got to do here is subtract 10y, subtract 10y. We'll be left with 16 minus 17y is less than or equal to -4. And then bring your 16 to this side. We're going to subtract 16, and we're going to get -17 is greater than or equal to 20. And here is where, whoops, 17y. Let me rewrite that. And the reason why I chose this example is because when we can't have a negative, if we were to divide 17, we can't have negative y. They always have to be positive. And when we divide negative 17, divide that by negative 17, if you're familiar with your signs, multiplying and dividing signs, those are the same. If you're dividing and multiplying the same signs, they become positives. Opposites, they'll become negative. And we'll have a positive y and 20 over 17. But when you're dividing a negative number, the sign here is going to change. It's going to flip. It's going to come to less than or equal to. And then that will be your final answer. And I just wanted to show you that when you're dividing negatives with inequalities, it's going to change the signs and your greater than or less than signs. Any questions? Interval notation union. We'll be moving on to that. I think that was interval. So I guess we did that. Sorry. The interval notation union, that one was the when we dove into the inequalities on a number line. So we did that. We'll be moving on to compound inequalities. And compound inequalities is joined by the word or. The word or is when your inequalities, you're going to be getting two. like -2 is less than x, and x is less than 1. And this equation is called conjunction. And it's just like in our last problems that we went over. Like we graphed this x then when we graph that on a number line, let's say this is -2. It's going to include everything to your positive side. And then we're going to take this side, the other inequality, x is less than 1. And that is going to include everything that is on the side from 1. And when we're given two inequalities to put on the number line, it's going to look like x -2. It's going to look like that. And all that is saying is that it's just going to include everything between -2 and 1. From that point to this point, everything that falls within that portion of the number line is going to satisfy this equation. And there's a lot of rules to this too also. We could have A is less than and x is less than b, and can be simplified to A is less than x less than b, and vice versa. B is less than x and x is less than A. When we write that out and simplify it, it'll be B is less than x B. And then that's all that it is saying. We could be given, I'll give an example of what I mean by this. We could be given a problem like -1 is greater than or equal to 2x plus 5 and 2 plus 5 is less than 13. And when you're given a problem like this, they want you to isolate. And isolate again is bringing our x by itself. So what we're going to do here is subtract 5. We're going to get -6 is less than or equal to 2x. Divide that by 2. And -3 is less than or equal to x. And we're going to do the same thing to the other side. We're going to subtract 5. We're going to get 8. 2x. Divide that by 2. And we're going to get x is less than 4. And when we graph this equation out, it's going to look like this. Notice how we have the less than or equal to sign on this one. So we're going to bracket this part because we're not including -3. And this one doesn't have it, so we're going to be including 4. And it's just going to be everything within that portion of that number line, not including -3, but up to 4. That's going to satisfy that equation. And that is compound inequalities. Any questions? Moving on to intersection absolute value equation. So in this one, the absolute value of x equals p. It's always to satisfy x equals p or x equals -p. And if x equals 0, that is equivalent to equation x to the equation x equals 0. But if we have an absolute value of x but equals -p, and then that has no solution. Like we could be given a problem like 2 absolute value of x plus 5 equals 9. And if we were to bring the 5 to the other side, subtract 5, we would get 2 equals 4x absolute value 2, and then divide 2. The absolute value of x equals 2. And all that is saying is that's one solution, and the other one is it's 2 absolute value equals 2, and negative 2, the absolute value of negative 2 equals 2. So those two check off. And like, let's say we had a negative 2. We have x, the absolute value of x equals negative 2. If we were to throw in the absolute value of 2, the absolute value of negative 2 equals negative 2, but that checks off. If we were to have the absolute value of negative 2 equals 2, and then, but that doesn't check off. So there's a little unbalance with that. That's why I say when x equals negative p, it has no solution. And let's say we're given a problem where the absolute value of x is less than or equal to p. And that's where this whole this portion of it comes in, the absolute value of 2. All that is saying is on a number line, any absolute value, I'll go with that one. We have x is greater than or equal to p, or x is less than or equal to p. So when we graph that, it's going to look like negative infinity to negative p, bracket, we're going to have that u there, bracket, positive p to positive infinity. And when we graph that, it's going to look, your graph will look something like this. We're taking everything from negative p to negative infinity. Everything's included. That's going to satisfy that equation. And everything from positive p to positive infinity. And that's going to satisfy that equation, except for what's in this portion of the number line, including the p's, I believe. And any questions?
We have a question. We have a question, Terrence, from Facebook. It says, on the number line, what does the parentheses and brackets mean?
The parentheses mean it's including everything that is also P. The parentheses include everything and that number, but the brackets mean it's not including that number. It's just like from, let's say 2.1 is P, and we have our bracket here, or our parentheses here, 2.1, or 2. Let's keep it 2, a solid 2. The parentheses mean that we're including -2. We're including the P, any absolute value P. But when it comes to the bracket, we are not including the P. We're not going to be including 2 if 2 was our absolute value. Does that clarify anything? Make sense?
Yes, they said thank you.
Okay, moving on to our last section, it's formulas. In the formula section, we're going to be covering the perimeters, areas, and volume. Okay. So the first one we're going to do is the perimeter. And when we're talking about perimeters, with this shape, we could be given like 37 inches, 44 inches, 20. When we're talking about the perimeter, all we're doing is, no matter the shape of what you're given, if they're asking for the perimeter of it, you're just going to be adding all these all together. And like we're going to be taking the perimeter equals 29 inches plus 19 inches plus 37 inches plus 44. And if we were to add that all together, our perimeter would equal 129. And that's the only thing that I believe you need to know about perimeters. Any questions on that? Before we move to areas. Moving on to areas, there's a few formulas to keep on hand. The first one I have is the area of a parallelogram. And then that would look something like this. And the area of a parallelogram is area equals base times height. And in this example, we could be given, this is our base. Let's say this would equal 5 or 7 kilograms. And this here is your height within this equation. It would be 5 kilograms. And then you just plug in and multiply. So it's just 7 kilograms times 5 kilograms. And that's going to equal 35 kilograms squared. The next one is a triangle. You could be given something like this. And the area of a triangle is area equals 1/2 base times height. And the book will give you something like your base could equal 9 meters. Your height could equal 6 meters. And then you just do the same thing. Your base, plug in 1/2 times 9 times 6 area equals. And then when you multiply that out, you'll get 9 times 6 divided by 2. Area equals 27 meters squared. And always remember your units or your but you're multiplying kilometers, meters, centimeters squared. Those are all crucial when you're trying to find the area of a shape. And the area of a rectangular equals the area equals length times width. And this one is pretty much straightforward when you're trying to find the area of a rectangle. It's going to look like 3 area equals 3 centimeters times 4 centimeters. And that's going to equal 12 centimeters squared. And we're almost there. The next one is a square. The area of a square equals side squared. You're just straightforward. An equal square. We have 9 meters. 9 meters. There's also another equation with this. You could use this formula, Or you could use area equals side times side times side times side. Either or, you should get the same area. So we have area equals 9 squared. Area equals 81. Or area equals 9 times 9. That's meters. Should be meters squared. 9 times 9 meters. And we're multiplying meters. We're squaring meters. Multiplying meters twice, so it's going to be meters squared. 81 area equals. So you should get the same thing. Then the last, any questions with this? Confusion? I have one more area I want to go over. Let me erase this. The last one is a trapezoid. And the area of a trapezoid equals 1.5 times height times A plus B. Or area equals A plus B divided by 2 times height. Example of a trapezoid. So your 18 is your base. Your 7 is your height. And 12 centimeters is your A. And then you just plug in and work with your parentheses first as pandas. So it could equal, I'm going to go with this one, this formula here, 1.5 or half times 7 centimeters times 12 plus 18 centimeters. So 12 times 18, or 12 plus 18, we get 30. And since we're going to be dividing the whole, this whole equation by 2, we're going to be, you could rewrite that like 7 times 30 over 2 equals. Then this 30, the 30 here, you can break that up into two numbers that could multiply into 30 and work with cancellation. I don't know if you guys are familiar with that. Like the 2 can go into 30 15 times. So we can write that as 7 times 15 times 2 divided by 2. And then we could cancel out the 2 here. So what we'll be left with is 7 times 15. And then that would equal 105 centimeters squared. Confusion? Questions? All right, moving on to the last portion is volume. The volume of a sphere the volume equals 4/3 pi times r cubed. Okay, volume. This one is basically the same way. You have to be given an R value to plug in as a sphere is like from the center of a ball on out to the outside of it. That's what we're finding. And so we could just plug in and play 4/3 pi times 4.2915 inches cube. And when you plug that in, you could get an approximately 33106 inches cube. And that's the volume of a sphere. And the next one is a volume of a circular cylinder. And that is the volume equals base times height, or the volume equals pi r squared times the height. And a circular cylinder could look something like this. And then you could be given your height at 12 centimeters. And here is your R, which could equal 4 centimeters. That's this little guy here. So here you could do either or. You should get the same. You should get the same answer. But keep in mind, if you're going to use this one, you have to multiply your 4 centimeters 2 times, which is going to be 8, because it just says base, but we're given just the R value, and that's the R is like, I believe it was just half. And the one I'm going to use is this one. The volume equals pi r squared, which is 4 squared times 12. When we plug this into a calculator, we're going to get 50.265. 4 times 12, and which is going to equal 603.185 centimeters squared, I believe. And then that will, and that's an example of how to find the volume of a cylinder. Then the next one I want to go over is a rectangular solid. That one is volume equals length times width times height. You'll be given a cylinder like, or a rectangular solid like this. Let's say this is equal to 10.5 inches. This is equal to 18 inches. And this little portion here is equal to 5 inches. So the length, so let's plug in and play. Volume equals length times width times height. This one here is be equal to, our length is 18 inches. Our width is equal to 10 times 10.5 inches. And our height is 5 inches. And then you just multiply these all together from left to right. So we're gonna get 945 inches cubed. Any questions? I have one more volume formula I want to go over. Then you guys are free to go. Not that I'm keeping you here. Let's see. And I know I went over. Sorry about that. The last one I forgot to go over was the surface area. We'll name that SA. That'll be your surface area. And the formula for that is 2LW plus 2H plus 2 with height, or okay, with this one, you could be given, find the surface area of, and with this equation, we're finding the surface area of all the sides, and then we gotta combine them all together. Like this one could be 7 meters. This one could be 10 meters. This one could be 8 meters. And the formula I'm going to use is this one here. So we're going to be given 2 times 10 meters times 8 meters. Plus 2 times 10 meters times 7 meters plus 2 times 8 meters times 7 meters. That's the surface area. And as you can see, we're finding the surface area of each side. And when we multiply this all out, we're going to get 160 meters squared plus 140 meters squared plus 112 meters squared. As you can see, I did my multiplication first before I added. And then now we are going to add all these together, which would give us 400 and 12 meters squared. And I believe that concludes my presentation. Do we have any questions?
Alrighty, cool. Is there any other questions for Terrence? If not, we're going to go ahead and post the evaluation link here in the chat box. So Audrey will post it now. Remember that the evaluations are crucial in, us counting your participation in these events. So it's part of the gift card giveaway. So as you can see, you can also read the little chat box there that sort of explains the gift card giveaway for you guys. So if you attend 5 events, you get entered into a raffle for $25. You attend 10, you get entered to a higher one, and so forth, all the way up to 100. So thank you guys for joining us here today. So remember to fill out the evaluation form. And then we have our last event for today at 3 o'clock with Joyce. She'll be going over finding a voice. If you're enrolled in some English classes or writing courses, she'll be going over tone and mood and what kind of tone and moods are out there that depend on the type of writing you're doing. So they'll be at 3 o'clock today. So yeah, thank you guys for joining in, and really appreciate you guys' participation. So Biga, just remember to fill out the evaluation. Thank you, Terrence.
Yep. Bye. Have a good day.